Maggie Delaney and Shababa present Hemodynamics! Now, you might be wondering, what is hemodynamics? Hemodynamics is the study of blood flow and the forces involved in the cardiovascular system of the human body. In this video, we are going to discuss two key concepts, forces and motion. First off, let's talk about forces. As blood travels through blood vessels in our body, four main forces are acting upon this blood. First off, the heart. The heart is responsible for pumping blood and keeping blood circulating in the body. The heart is an applied force as it acts as a pump, pushing the blood around the body. Next is blood. Each blood cell pushes on others. This creates a normal force of the blood pushing on other blood. Finally, we come to the third and fourth forces in which are created by blood vessels. These blood vessels contain the blood and exert two opposing forces through their elasticity. This means that these are elastic forces as they can expand and contract with the flow of blood. Fun fact! Hemodynamics differs from hydrodynamics, which is the study of flow of water, because of this elasticity. Now that we've got our forces, let's put them to work. We can now draw an interaction and force diagram for these situations. Interaction diagram. The system is a blood cell. Acting on this system is the heart, which is an applied force, the blood vessel, which is elastic, and finally, the other blood cells acting as a normal force. Note, this is an extreme oversimplification of the forces involved in hemodynamics. For instance, the forces of elasticity of the blood vessel is not only applied on the top or bottom, but all around the blood since the vessel is a tube. For our force diagrams, we first draw our normal and applied forces on the x-axis, which equal each other. Next, we have our elastic forces on the y-axis. These are also balanced. As you can see, all four of our forces are balanced, leading the net forces of both x and y axes to be 0. This means that there is no acceleration, therefore the blood is traveling at a constant velocity. One key idea in understanding the forces of hemodynamics is pressure. Pressure is a measurement of the amount of force exerted per square unit of area. This pressure is created by the moving blood cells pushing outwards on the blood vessel walls. Pressure is measured in a unit called pascals. Pressure is equal to force divided by area. Using this equation, we know that the formula for force of blood is F equals PA. So let's say we are solving for the force of blood in the aorta, where the pressure is 13,000 PA and the area is 5 centimeters squared. Then the force is 6.5 times 10 to the power of 4. That's a lot of force. That's enough to push a car. That's enough to push a lot of cars. That brings us to part 2, motion. As we discovered in the last part, blood travels at a constant velocity away from the heart. This is displayed in our position time graph, our velocity time graph, and our acceleration time graph. It is also displayed in our velocity vectors, which are equal, and our motion diagram, in which all our points are separated by equal intervals. Next, we are going to talk about the total cross-sectional area of a blood vessel. When solving for velocity of blood, we must use the total cross-sectional area as opposed to delta x over delta t. So let's say we're talking about the aorta again. If the total cross-sectional area is 5 centimeters squared, then the velocity is 40 centimeters per second, or 1 kilometer an hour. This is as fast as you walk. This is almost as fast as a speedy turtle. Overall, there is still a lot to learn about hemodynamics. It's crucially important as proper blood flow is vital to staying healthy. Blood flow does not only exercise the heart, but supplies the body with oxygen, keeping us alive. There's a whole lot more to learn, but that's it for now. The end!